Very good. Well, this afternoon's session, this first one, is called We Need to Talk About Regen. What does sustainable farming look like on Lowland Peat? And as described and mentioned earlier, regen is often wafted around as the magic word to answer all our problems. What would it mean on peat? And to what extent, what's the actual, well, let's get some rigour in here. What actually needs to happen in order to make it work for all the things that it's supposed to? That is to say, carbon, wildlife, and of course, food as well. So we've got a great panel in front of us, and it's going to be a similar format to this morning, sort of 10, 12 or so minutes each, and then time for questions at the end. So please do think of some nice thorny questions for them. That's all the ones I like. So we're going to go straight into Nick Padwick from Kenhill Estate, who is going to talk and make an introduction to regen farming. Thank you, Nick.
Thank you very much for being on. Green one, is it? Green forward. Yeah, thank you. So, guys, I've kind of got the graveyard shift, so I want to see how many people fall asleep after your exceptionally good lunch. So, Kenhill. So I'm going to take you on a journey away from your lovely fens and take you to some mineral soils. And we are situated on the Wash. We're about 4,000 acres of sand and silt, with only 18% of our soil being clay. So Kenhill, when I joined 6 or 7 years ago, we had a massive transition. We wanted to move away from our conventional focus in agriculture, so lots of sugar beets, lots of spring barley, lots of chemicals, lots of fertilisers, lots of traffic, lots of expense, and certainly ploughing and cultivating, we were using an awful lot of steel, which was costing us an awful lot of money. And we decided to enter into a very ambitious higher tier stewardship scheme, and we took a lot of land out of production, which is the rewilding area. So we took out 500 acres of arable land, which in my experience of agriculture, which is this year's my 43rd harvest, we should never have been farming it. I've never seen black grass like it in my entire life. And brome was just ridiculous. And we were making a margin probably 1 year in 5 if we were lucky, and that's before the fixed costs. So we decided to do something totally different, and we put it into a rewilding project. So we've got 500 acres of woodland, 500 acres of arable land that's now been converted to WD5 or WD6, and we've got 20 cows, 20 horses, several pigs in there with a ring fence around the 1,000 acres, and it brings in a good return for us, certainly better than farming. Traditional conservation on the Wash, so that's fresh water. We got a nice grant from under our stewardship scheme to put in some barriers, and we're now retaining water on the marsh, and we've got lots of wildfowl and waders. So that's our traditional conservation. Traditional because we can increase and decrease the water levels, which is really important, so we can manage that. And then we've got our regen farming element, and of course everyone in this room is a regen farmer, I'm sure, so we'll go through the principles of what I believe regen farming is all about and our journey. And remember, this is our context, so I'm not suggesting to you guys that you do all of this. We really want to farm in context of what we've got at Kenhill. So the first thing, many years I've been farming, and I've been sending my soil samples to all sorts of different people to get analysed, and I came across this very interesting sample. So there's a picture of our soils, if you can see it, and then there's the result. So according to that result, that is a clay soil with pretty good microbial activity. Well, actually, when you put some context in around that, that sample stayed in a bag for 3 months in a rep's car because he forgot to deliver it to the analyzer, and it said it's got really great microbial activity. Well, if I stuck you all in a bag, sealed it up, and stuffed you in a car, there wouldn't be a lot of life left, I wouldn't have thought. So I started to think, well, come on guys, am I missing something here? Do I really want to move away from chemical fertilizers and herbicides and pesticides? Yes, I do. So what's going to recycle stuff in my soil? Is there anything that's recycling stuff in my soil? Because there was nothing taught to me back in the 80s when I was at agriculture college. Until I came across Elaine Ingham and started looking and exploring the soil food web. So we are looking at the principles and practices in around the soil food web, and that's not the only thing we do. So it's one part of what Ken Hill is about, and I'll talk about the other elements in a second. So we started looking at our soil succession, where we were on that soil succession scale, and I've done over 400 soil samples all across the UK, and most of the soils are between, on the first sections, bare soil and weedy soils. That's what our systems have currently provided us. We need to get, if we're growing row crops, wheat and barley, we need to get into the productive row crop area. So that's increasing our microbial activity in our life and our soils. How am I going to do that? Well, I'm making compost, right? And those 3 rings of compost are not going to change 4,000 acres of agriculture, right? That's just not going to happen. But we can manipulate those composts to give us the microbes we need in our soils. And of course, measuring. Absolutely measuring everything we've got in our soils. So I'm sure all of you know what that little thing is down here. Can anyone shout what that is? Oh gosh, right, that's a testate amoebae, okay? A protozoa. So we're identifying what microbes we've got and the use of those protozoas within our soils and how they're going to recycle the bacteria into ammonium in the soil profile. So measuring is really important. The SFI and CS, really, really important. So we're now able to utilise all those options within our growing rotation, and we've got an understory of clovers and legumes in our wheat. We row it, we take the wheat off, we let the clovers grow, we then harvest the clovers, and we make windrows of compost, wood chip, greens and high nitrogens to make some fantastic compost which we then recycle and use either as compost on our soils, or we extract the microbes from it and apply the microbes individually. All depends what and who we are targeting. So our soils typically look like the ones on the left-hand side, and that is an application of 5 tonnes a hectare of compost. That's on one of our fields. Once we'd applied that, we applied 6 by 400 litres a hectare of extracts in 1 year, and our soils turned into the picture on the right. So the first time in my life I've ever dug into soils and found fungal hyphae. Just like that. Without going under a microscope, you could see it. You could smell it. It was absolutely sweet. Application methods, we're using lots of different ways of applying this stuff at large scale. Fine if you've got a small little garden or a plot of veg and you can apply this stuff with watering cans, that's great. But if you've got 4,000 acres and you need to apply large volumes of extracts to try and inoculate the soils, how are we going about it? And you can use totes, so we've got these totes up at the top here, which are interesting, and we just bubble all the microbes out of it with air, or you can then move to this system where we've developed a cage that goes into a sprayer, we pour the compost in the sprayer, and we can actually apply the microbes. So you end up with, in the basket, washed chips. So all those microbes have gone out of that compost into the water and then been applied. Results. Moving on, so you guys, I'm sure, want to know the results. Okay, so you're telling us you're doing this thing. What are the results of all your work? So we've taken a bit fuzzy, I do apologise. So we've taken, this is over a year, we've taken our soils which had very, very low microbial fungal activity, very, very high bacteria, and we've seen the bacteria reduce, go up slightly, the fungal hyphae improve, the protozoa have over doubled, nearly 200,000 micrograms per gram, and that's why the bacteria have gone down, because these bad boys are chewing up all this bacteria. Our fungal to bacteria ratio is at 0.6, it needs to be at 1, but we're moving the dial. We've come from such a low place in 1 year, but we can do this. The other thing that's really interesting, I mentioned that when I studied with Nicole Masters on her CREATE course last year, was microbes are great, but that isn't the only thing. We need to start looking at trace elements. And SAP testing is absolutely vital on this journey when you go cold turkey like we did, going from 4-8 applications to nothing. So we have seen an increase by using microbes of those major elements within our soils. Now we will continue to apply those through SAP testing, really, really important. And another thing for us is water infiltration. So 2 or 3 weeks of dry weather in the old system, we would lose tillers, plants would die, yields would drop, however much fertiliser and chemical you'd apply to them. We want to start improving those soil structures to hold on to those water, or onto that water, while we have those shoulders of very, very dry weather or very, very wet weather. And there should be a little video there. So that's just a field of view. There's a little flagellate going across the screen. That's just a field of view of a compost sample, so a soil sample that we took on that soil that's really improved. You've got a lovely fungal hyphae in the middle there, you've got spores, protozoa, bacteria, flagellates, the whole gambit of everything we need to do to recycle stuff in the soil at Ken Hill. Thank you.
Just a couple of questions while they're fresh in my mind, just factuals. It looked from the water infiltration, like the water infiltration had got worse. Did I misunderstand that in the treated soil?
It's getting better.
It had got better.
We can go back and have a look at it, but it is getting better.
Right.
So we're able to see a reduction into the blue. You see the reduction in the time it takes for the water to go through the soil profile.
Forgive me, I hadn't twigged that it was a
Yeah.
time measurement. There was something else I was going to... No, that's just a clarification. So thank you very much indeed for that. Next we have Ian Robertson from Hutchinsons, who is going to talk about mineral soil microbiology and, of course, Regen Ag. Thank you.
Afternoon, everyone. Yes, Megan gave me a lovely title, and only 15 minutes. So anyone that's listened to me before will know I will not do this in 15 minutes. So I'm going to be as quick as I can. And hopefully, Nick and I haven't seen each other's presentations until this afternoon, so they think they will segue quite nicely, and I think Liz is going to follow quite well afterwards, hopefully. So we branded ourselves Healthy Soils, and I think what I'd like to change straight away is that brand and call it Functional Soils. And more people will be talking about healthy soils. I'm involved in advising farmers from the Welsh Hills down to the Fens, and a healthy soil is different everywhere I go. And the functionality of that soil is even more important, because the functionality to grow a lettuce or grow a sheep is quite different. So I'll talk about building resilience. Nick just showed you earlier all the things he's been doing to improve his soil infiltration rates are all leading to better productivity, more functionality within the soil. And we talk about microbes, everyone talks about microbes. I can't get my head around the amount of microbes in a soil. And I've tried to simplify it. So apologies if it doesn't work. But I've gone out there, and if you look under each nail, this is according to the NHS, you've got 50,000 bacteria. All put your hands up. You've all got 50,000. There's a lot of bacteria in the room. If you then take my hand, oh, it's not stopped working, my dirty hand, I've got 200,000, it really isn't working, 200,000 bacteria in 4 fingers. If you've got dirty nails and you suck them, please don't, but if you do, the chances are you'll get really, really, really ill. But there's only 200,000 microbes there. If you then spin that up into a soil, if you take some of the bacterial counts on different soils, and this one highlights a bit better, you've got 4 to the times of 6 in a gram. That was a lot of fingers. Huge amounts of bacteria in that soil. Now these guys are good guys, bad guys. They're all there for a reason. This is nature. So the role that we're trying to do when we start talking about soils is enable nature to do what we want it to do. Build the house right for these guys, which is a huge army of stuff, to work for us in the way we want them to work. When we look at soils, this is a really old slide, apologies, but it's really important that we think about soils in the physics, the chemistry, and the biology. There's a lot of talk about biology. I think the ones we get hooked up on most is the physics and the chemical. Because historically, you can always see what you've done when you do something chemically. Let's say spray some Roundup, glyphosate, the field goes brown, or you plough it, it goes green to brown. What has been the knock-on effect on soil biology? And Nick put some work up from his farm, again showing that all his soils were bacterial dominant. There wasn't a fungi there, I don't think, or if there was, it was endangered. So all the work we're doing physically and chemically has had a knock-on effect. We spend a lot of time, or I spend a lot of time, measuring the chemistry of the soil, because I find it's much easier to get repeatable, when I'm moving between farms, if I do chemical analysis, it's ISO accredited, most of the analysis, and it's repeatable. When I start doing a lot of physical digs, we all look at things slightly differently, and biology has been really, really difficult to measure. It's been very expensive, and it's been the Preserve of Research Institute. That said, there's a new test coming out from Elaniti that is measuring the bacteria and fungi breakdown, that they're doing the next DNA sequencing, and they're putting it to functional groups. So I think this will be quite interesting. Again, take a look at Nick's farm, where he's been doing a lot of practical things. Has it changed the microbiome? And if it has it changed it for the better or for the worse into functional groups? So I think this is something that's very cost effective, and you'll see more of it in the next couple of years. Going back to what I was meant to talk about, the mineral soils, is if you take mineral soils, you've got sand, silt, clay. That's how soils are made up. Each of those sand, silt, clay perform differently. They have their good bits, like sand, it's got high bulk density. Got low nutrient retention, that's not good. You go to clay, high nutrient retention, low bulk density. So ideally, you end up trying to make utopia, which is 33, 33, 33. You get the best of everything. But the more important part is, if you're farming a mineral soil and you don't know your sand, silt, clay, it's very difficult to set out a cultivation plan or a cropping rotation, because you have to farm those types differently. There's not one blueprint to do it. And if you take your texture, your sand, silt, clay, is only sand, silt, clay. It is not soil structure. How you align or how you build with those through cultivations or farming practice is what gives you soil structure. There's so many farms I go on to say, well, I've got sand, it's awful. Well, no, sand's okay. How are you managing your sand? Or I've got often it's the heaviest farm in the country. They go, yeah, okay. Have you been out the parish? There's lots of, it's understanding what you've got and then farming it differently. Because if you take a clay and then you put really high potassium in it or high sodium in it, it totally destructures that clay. Clay will build organic matter better for you compared to sand. So there's lots of things. Once you know these things, it makes life so much easier. And then everybody is different. Nick, I'll talk about in a minute. Context, context, context. Everyone is doing something different. And what we're trying to do is start with this lovely thing here. Soil structure starts at 0.003 mil. But we all go out in the field and we do a visual soil assessment. We look at something the size of your hand. You go, oh, that's hard. You tap it, it's rock hard. Is it rock hard because it's a physical problem, a chemical problem, or a biological problem? No, I didn't know either. It's very difficult. Well, if you look at your sand, silt, clay, they start building up that microaggregate, sub-microaggregate, microaggregate, and then macroaggregate. Once you start doing chemical analysis, you understand what your sand, silt, clay is, what your humus is, what your cations are, how that micro or sub-microaggregate will form into an aggregate for you. The solution will always be, if I've got a very poor macroaggregate, I do physical cultivation. But if that's a biological or a chemical issue, the more physical cultivation you do, the more you oxidize organic matter, the worse that structure will become. So it's very short term. And why are we trying to get this lovely aggregate? Well, it's touched on before again. We're trying to build a really, really brilliant place for microbes to live in. And those microbes you want to live in are your second trophic, and then your third trophic, fourth trophic, etc. Most of the soils that we've been analysing over the last 10 years or so, we have absolutely masses of the second trophic, loads of bacteria. Really heavy bacterial dominant, which is fine, but actually we want something to date on those bacteria, and that's where Nick was talking about the Johnson-Su bioreactors, putting protozoas in to feed on the bacteria and cycle nutrition, because that's what nature does. We've interfered with it. And there's a line, organic matter is what we're really talking about down here. Very obvious thing, say the more soil organic matter in your soil, the higher the potential microbial biomass, because that's their food. And that's why again, the Regen Principles is all about creating environment for food to be in the soil, for the microbes to eat in that soil. I might get taken out with this phrase. Fungi is brilliant, but the fungi is going to solve our carbon dilemma. Well, maybe. They are much better at storing carbon in the soil. However, just another work that Ian Gould did at Lincolnshire University. Again, the more soil stability is growing with an increase in globalin, which is stable carbon. So it also makes sense. More fungi, more stable. However, if we get too fungi, we end up in a climax community, which is where we are not growing food. Nick mentioned earlier, we want to be in that middle bit with grasses and perennials. And that's roughly a bacteria to fungi count 1 to 1. Nick's soil was 0.2, I think, when he started. He's now got it to 0.6, so it's getting where it wants to be. However, every time we do disturbance, and what I mean by disturbance is chemical, physical, or biological disturbance, you take it back down to a more bacterial dominant soil. So we can't just think of doing one thing. We have to think about doing all those things together. And if you are doing all those things together, your soil will still respire. It can't stop breathing. And in breathing, it is releasing CO2. That's what nature does. I think Brian talked about earlier on about the more CO2, the greener the planet will be. But what we've got to do is we must always have stomatas above your soil. Capture the CO2 those microbes are releasing. Go about very simple regen principle, having a green cover on the ground. Capture it, put it back down as root exudates to feed more diverse microbial activity. Do not, please, have lots of bare ground, because that's not very good. But you know that. Point at that point. We find out if you are growing cover crops or you are doing any green biomass crops, we end up getting people to cut and weigh them and measure them just to see what you're doing. There's a small cover crop there had 1.5 tonnes of carbon in it per hectare. Now that's short-term carbon, but it's still short-term carbon energy going into the system to cycle. That is short-term sun's energy, giving you soil structure, so you don't need to burn 2 million-year-old sun's energy as diesel. And it's just allowing a bit of education going on there. There's also 156 kilos of nitrogen there. How much we get into our next crop all depends on how we manage it. But we should be doing these practices and changing how we're farming, not just doing them on top of our farming practices. And there was meant to be a nod for Megan into regen, so I'll put this up there. We've got agroecology, regen. We've all seen these principles before. Minimise disturbance, that's physical, chemical, biological disturbance. Keep the soil covered, yep, with a living root ideally, but if it's just stubble and some trash, that's fine. Maintain a living root, maximise diversity, absolutely so important. Everything we could do diversity with, blends, rotations, all those things. Cultivation depth, diversity. Integrate livestock. If we can't do livestock, then just think about what we just spoke about, which is protozoas. That's the livestock you're going to introduce. Nematodes. Bacteria and nematodes. Brilliant things. And then the mindset is the most important one. As I said, I work all around the UK, and that mindset piece is the bit that enables change on the farm. It's not just following what Johnny or Jane did down the road, it's understanding what we're trying to do on the farm, understand the parameters of your farm, and make a change onto that. So in summary, mineral soils are very diverse, and they need diverse management. Reduced disturbance of in all soil types will enhance stability and soil building. And that's not saying I'm against ploughing, don't get me wrong, I like ploughing. But I don't like ploughing. I like lintel, but I don't like lintel. It doesn't matter, context again. If you've got a really bad, compacted aerobic layer that only the plough will take it out and don't go there again. But don't think that it will just disappear for you and hope that you'll get rid of that compaction layer. You have to do something. If you ever do it with steel, make sure you put a plant behind it to stabilise what you've done. Manage physics, chemistry and biology attributes, and they will help create the biological that you want to be going there. They will feel the dream. Build it and they will come. Test your soils, chemistry and biology. You can do that if I send it to a lab, or just start taking measurements on your phone, infiltration rates, do whatever you like. But always do it at the beginning and monitor your progress, because some days it can be very wet and miserable in winter and you think you've gone nowhere. And you look back to those pictures from 5 years ago and it's a massive change you'll have made. But because you're so close to it, you'll have forgotten it. And at that point, thank you for listening.
Thank you very much indeed, Ian. Yeah, plenty to plenty to get into there. And next we're going to come to how does peat differ to mineral soils with Dr. Elizabeth Stockdale from
So Ian gave us a brilliant introduction and Nick put it in context, the other way around obviously, but those two things for how we might think about managing soils. There's a bit of a challenge for us though if we're thinking and working in the fens, is that we have soil but actually also not soil, because peat, well, is soil but isn't, and well, it's geology and it isn't, and well, actually we just need to get our heads around what makes peat different to allow us to take that context into account when we're thinking about what sustainable management might look like. So I'm going to be a real soil scientist now and take you back to soil formation for a moment, because every real soil scientist really wants you to use long, complicated words to describe the layers that they find in the soil, which are called horizons, which form perpendicular, approximately parallel, opposite of perpendicular, to the soil surface. And so we've got weathering up and organic matter added from the top. So the rocks below began to weather and mix with that mineral material on the surface, and we get mineral soils. And that's how mineral soils form. Those layers and things can become described. Not many fen soils look like this one, I am aware. But soil scientists like these pictures. There is a real great book of these pictures by Kubiena that describe those profiles, give the zones of weathering and the place where soil forms. That is where the biology and rocks come together. Now that's a bit of a problem if you're a peat soil, of course, because, well, the rocks are possibly 7 or 8 metres down. Traditionally, of course, if we think about our soils and how they form, and we've had some really good examples, here's just a diagram to remind us that we usually get this distinct layer of soil at the top where those minerals and cultivation through cultivation have been mixed together with the organic material that's been added through time. So a real distinct layer, a really active layer, a layer where change is happening, where new things are being formed, where fractal patterns of size and shape are formed. Brilliant fractal diagram for that formation of soil structure, and links us back to things Brian was telling us this morning about how structure is really important because the clay particles can wrap up the organic material and stabilise them against breakdown. In the subsoils we get that decline rapidly, though we can, if you go to the right place, and see those earthworm channels running into the subsoil. I commend you the soil pit at Cereals every time you visit, just for a wander through to see actually very large in front of you how all those interactions are happening. And so in those kinds of soils, the amounts of organic matter we find become this balancing act between the amount we're putting in and the breakdown and stabilisation processes in the soil. So traditionally, and since the 1930s, we've captured this description in the context of what we'll call Jenny, and he's a man, Mr. Hans Jenny's formation principles for soils, that if you understand the climate, the rocks, how long that soil sat still, you'll have a good idea of being able to predict what the soil looks like. And that's going to interact with topography, management, and many other things. But then there's peat. So all those things that I've just talked to you about, all that stuff I studied at university, all that soil science I tried to beat into poor people's heads, suddenly doesn't apply. Because actually in some circumstances, those things don't happen at all. And instead of organic matter mixing with minerals and it all breaks down, no, organic matter now starts to grow upwards. Because the organic matter doesn't really break down at all. The activity of the organisms in the soil is restricted by cold, or acidity, or wetness, and we see that at the top of the hill, but also in the basin at the bottom of the hill. So we get tropical peats in very warm places, well, because it's really wet and stuff just sticks around. And you know this, those of you who farm in the fens, because at the bottom of many of your soils, there are still trees, are there not, that have stuck around for thousands of years, very safely sitting there, not breaking down at all. So we've got this really slow breakdown, usually a very small aerobic layer at the surface, something that soil scientists now can't even call an A to make it the top. They have to call it an O because it's so dominated by organic material. It's humified because that top little bit is aerobic. And so we've got this accumulation growing upwards of the soil from, well, actually, top down. There's no bottom up here going on. We might actually have started with a mineral soil. And in most cases we have. 10,000 years or so ago, and in different locations, different amounts of time. We've started with a mineral soil that was, you know what, it was wet and horrible and claggy. Actually, it could have been a sand and gravel that just had high water tables because of where it was next to a river, or it could be a really wet clay. In general, in the fens, it's because, well, you're at the bottom of a hill. You get all the water from the Trent and from everywhere pouring down and filling the basin. The interaction between the sea and the water coming down gave you waterlogged soils that built up and captured fossil carbon. And as soon as we've got more than 40 centimetres of O horizon, the soil scientists go, it's peat now. And the geologists wait a bit longer before they put it on their maps as peat, and it's one of the reasons we struggle to make our maps match, because we have slightly different definition. So those humic groundwater glaze soils might be typified by fen car type alders, wet ground. We've got that mineral surface with a summer water table and then a winter water table, so they're drier in the summer than the winter. This is not a surprise in the UK. But that means in the middle of there, and it's important for something in a minute, we have iron being oxidised and reduced and oxidised and reduced, so that we get this mobilisation of iron in these soils too, and the surface accumulation of heat. So this iron oxide is what Nick has plentifully in its iron 3 form in his soils, in those very aerobic soils, giving you a pretty darn orange colour in those sandy soils. But under anaerobic conditions, and you will see it in your wetlands, that starts to go blue-grey in colour. We start to see these channels where roots have entered that allow then some spots of rust to reform where oxygen goes back in. And so we get this switching and this real visibility of waterlogged systems, and in that system, the mineral, the microbiology, that action, that food web, it's not the same. It's a hugely differently adapted food web that's coping with actually being able to breathe underwater quite a lot of the time and use iron as a terminal electron acceptor. There's a very long scientific term for you, but it's using that iron as a way of replacing oxygen in the way that it breathes. It does it with other chemicals too, and allows that microbiology to keep on working slowly. Now, in the fens, it's really important to watch out, especially as our soils shrink, as we come closer back to that mineral material, for acid sulfate soils. Because when the fens were invaded by the sea, we have had the formation in those soils of sulfide minerals. So iron now directly bonding with sulfur, and when those are exposed to air, what we're going to get is very fast production of acid, and it's not going to stop anytime soon. This formation of acid is going to outlast me by a long way. It's going to outlast everyone in the room, even if we added all the years we had left. Well, the pH in the soil material that we've got exposed is going to fall really quickly as soon as it's exposed, and it's going to fall below 4.5. Now that's a bit of a problem for crop production, and is going to be a problem, is an increasing problem across the fens as these bits of soil become exposed. And we can spot it in part because our drains will start to pick it up for us. So ochre in the drain is a starting reminder that this could be a problem under our feet. And actually watch it out. The place to really see it is actually when ditch spoil won't even grow weeds anymore. That pH 4.5 will really limit what's going on there. Now it has to be said, not much microbiology is going to like that, and there isn't much we can do about it. That chemical process is absolutely going to dominate those soils. And in other parts of the world, it's this process that's taking soils really quickly out of production. So we're going to have to keep an eye open for it. But if we want to manage these soils well, we need to also understand what's different about fen peats than mineral soils. And of course, most farms have a bit of both. So most of you are going to have to keep Ian's principles in mind, and mine, and kind of make all this stuff work in one. It's a terrible place. So let's just get our heads around this. Nutrients. If we're thinking the fens, and there are people in the room from other lowland peat areas, I apologise. These guys have been receiving water from a huge catchment area for a really long time. The minerals that have been weathering upstream of here have been accumulating in the fens, and hence these guys, in a way that isn't true, and I can see people from the Lancashire mosses, and I know there's people around from the Somerset levels, aren't quite the same. The levels are a bit of a receiving area, the moss is much less so. So the fens are an accumulation of, well, 10,000 plus years of nutrient accumulation. Now we've got runoff from everywhere else, marine incursions. That means we've got some really odd patterns, potentially, of chemistry to keep Ian really on his toes. Hang on a minute, how's there a high one of those in the lowland? I never see that anywhere else, only in the fens. But those high nutrients in peat can all mean high indices, but don't necessarily mean high availability. So just because we measure a lot, even in available forms, doesn't mean that the plant roots will be able to use those nutrients really effectively in these soils. There's a problem, actually, with a number of our chemistry extractions when we apply them to pure organic materials. And so we have to just take some of that stuff with a pinch of, salt, to think it through. So manganese, particularly copper and zinc, even if those indices look reasonable, could be an issue. We know, of course, that the decomposition of our peats under drain conditions could give us really good nitrogen release. And they do when the soils are warm. So we've got a high overall seasonal nitrogen supply, because we don't want lots of nitrogen only when the soils are warm. The time we really want nitrogen for crop production is actually in the spring, when the soils aren't yet warm, and when they're still setting wet. So actually we won't always have very good control over our nitrogen supply. And just ask anyone who's trying to grow lettuce, there are plenty of them in the room. Getting that balance right from the nitrogen supply is really tricky. Right, water balance. Well, mineral soils, really easy. They get wet when it rains, and then they dry out, and they get wet again, and it's beautiful, and it just works every time. Infiltration rates, really easy to measure. Flipping peat, it's got this thing called hysteresis in its water release curve. That means it doesn't wet up the same as it dries out. It has a hugely different pattern. And if it gets too dry, well, it now becomes hydrophobic. It pushes the water away. So actually it doesn't re-wet at all. So a hydrophobic peat layer at 30 centimetres will act exactly like a compacted layer. And we'll get a place where, well, it doesn't wet up and roots can't get through, and actually now it's acting as if it's compact, but it isn't, it's just not re-wetting. And actually the only way we can deal with that is probably to put a piece of metal in, not because there's compaction, but if we can break that open, we can allow some water through to allow re-wetting to happen. So that links us through to the physics of these soils, flipping light and fluffy. Doesn't go through cultivators properly. How dare it? It just doesn't do what the machines want it to do. Actually, we could do with some specifically well-designed bits of cultivation equipment for peat soils rather than trying to use the stuff that was developed on mineral soils. It's just no one's quite got round to it yet. And weed control. Or, shall we say, weed lack of control, perhaps. Because all that chemistry that's been developed for using on mineral soils really doesn't work on peat soils. The organic colloids at the surface in that OH layer now hold on. They adsorb those herbicide molecules and stop them doing the job to control the weed. And we've got a higher weed seed bank anyway, and I think that's a really interesting question that I have asked some people and no one can tell me the answer. Why? Is it just because they've grown well and we haven't controlled them over generations, or is there actually something about weed seeds and how they are not decomposed, I think, perhaps, with a different soil microbiome in these peat soils, not actually really consuming or predating the weed seeds in the same way? I think it'd be a really interesting study if only I was a weed scientist. Oh, and then there's carbon. Carbon, the thing that's driving us all mad at the moment, because it would be great if we could focus on getting the cycling of carbon at the surface right for peat soils and fix everything. If only we could get that mineral soil carbon cycle, the one that Ian and I can just about know what the principles are and how we might manage it, and apply that onto our peat soils and fix everything. The problem is we can't. It works in that top 10 centimetres, but actually an awful lot of the carbon that's coming from our peat soils is from that fossil carbon. That carbon that was left behind generations upon generations ago when the soil was wet and actually isn't stabilised because it's not held to mineral materials, and if we just dry it out, what's it going to do? Well, it's going to break down. And there's very few mineral materials there to hold it steady, so the only thing we can do if we want to hold on to that carbon, that fossil carbon, well, is to make it wet again. That's not going to be a great outcome if we also want to farm. So we're going to have to think really carefully if we want to put together some regenerative practices that are going to work really well on peat. They're almost certainly, I think, not going to be the same. At least not all of them. On mineral soils, that focuses on the contemporary carbon cycle, that soil biological activity, supporting and driving soil health through management of physics and chemistry effectively to create the environment for the biology. But on peat soils, we've got to think about that fossil carbon as well. And so water balance and managing water is going to, I think, sneak in as a really key principle in what we're doing. It's not there, it should be, I think, actually, even on mineral soils. Drainage, a really important part of those principles of soil management that we put together for HDB. But on peat soils, a really different way of thinking. There's going to be loads more work to do. But that's where you all come in, isn't it?
Thank you very much indeed, Elizabeth. That was great. A lot of information there for anyone who's farming on peat or indeed anywhere else about their soil. Now, we're going to talk about how retailers approach peat and net zero, the WWF basket of metrics with Swaantje and Marten from Padwick.
That was a surprisingly good pronunciation of my name, thank you. Hello everyone, good to see a lot of you who I've met at the DEFRA Lowland Peat Forum. Someone there called me Panda Lady, and I've decided to just fully lean into that today, so if you want to find me, that's me. For everyone else, I'm just Swaantje or Swaantje. I lead the business advocacy work at WWF UK on sustainable agriculture. And if you thought that so far all the presentations have sort of very smoothly fit together, I'm here to give you a completely different view that has nothing to do with sort of soil expertise. So you can see that as your sort of interlude before the next panel. So yeah, I'm not an agronomist by training at all, but I bring hopefully a different useful perspective to this panel, and that's the role of the retail sector in solving the peat problem. So, right. I should start by saying that through the WWF basket and the retailers' commitment for nature, 7 of the major UK food retailers, representing over 70% of the UK food retail market, have committed to lowering their emissions in line with a 1.5-degree science-based target by 2030, which is why I'm here talking about the retail sector. And I would argue that if retailers are serious about this commitment, then reducing emissions from peat needs to be part of their playbook. So in the next 10 minutes, I just want to highlight 3 non-exhaustive ideas about how the retail sector might contribute to solving the peat problem. But I think first, and I don't want to spend too much time on this because I think others have outlined this in a lot of detail already, but just to spend a second on why I think we need to talk about supply chains. It's a bit of an uncomfortable topic for many because as someone at the DEFRA Lowland Peat Forum put it, we all love food. So no one really wants to stop growing it. But I think it's a point that we really crucially need to tackle if we're serious about solving this issue. So I think none of these numbers are new to anyone, so I'm not going to belabor this point too much. But I think they outline quite clearly that we need to figure out how we're going to deal with peat in our food supply chains. And I guess that's why we're all here. So this is uncomfortable because at the same time the government and the minister had outlined this again this morning, has rightfully announced an increased focus on food security and increasing British production of fruits and vegetables. At the moment, the UK imports almost half of our fresh vegetables and about 85% of fruit. And that is despite us having a pretty excellent climate for producing these things here, except perhaps this winter. And arguably, if we want to see a dietary shift towards more plant-based foods, then we need to grow more of this stuff and not less. Moving production off peatland completely might be the most effective way to stop peatland degradation, but it would effectively increase the UK's reliance on imports and displace the environmental impacts to other sourcing regions, as Tom also mentioned before already. And many of these sourcing regions are already suffering from water scarcity and soil degradation themselves. So, the million-dollar question is then, of course, how can we combine food production with sustainable peat management? Or in even bigger words, how do we solve the triple challenge of ensuring food security for all, keeping global warming to 1.5 degrees, and reversing nature loss at the same time? Quite the question. As with most complex problems, there's no silver bullet for this, and finding the balance between food production and peat restoration will require careful and context-specific analysis. So I think the first action I would call on retailers to support is to improve our understanding. Improving our understanding of where peatland is in the supply chains, what condition it's in, and how it is being used at the moment. And I think the opportunity mapping that Megan has presented earlier on, that's been conducted with farmers, land managers, and drainage experts in the fens, seems like a really good model that could and should be applied elsewhere. The forthcoming land use framework, much awaited, and the updated England peat map could be a first good step in that direction, but they might not provide the needed granularity to design realistic solutions that are achievable at a local scale. So I would therefore argue that retailers have quite a unique role to play in mapping out their own supply chains in more detail. This would enable retailers to explore wetter farming for certain crops, or moving others which are equally suited to cultivation on mineral soils away from peat, such as potatoes, cereals, or sugar beets. Secondly, retailers need to collaborate more when it comes to peatland. Collaboration has been quite a key theme that's been mentioned by a few people today already, and retailers are no exception from that rule. Many retailers source from the same suppliers, and I know we have quite a few from G's Fresh in the room, so that's probably ringing true to you. And so this means there is, on the one hand, a big data sharing opportunity here, and on the other hand, it also means retailers should agree and collaborate on an approach to managing lowland peat in their supply chains. Because the same grower will struggle to adhere to two different sourcing policies or data requirements if the produce is essentially coming from the same field. Areas for collaboration might include funding research projects together to figure out what sustainable peat management could actually look like and which approaches would be most promising in different areas. Or also creating cross-sectoral schemes that support and incentivize sustainable peat management among suppliers. I find it very encouraging to hear that a retailer group on peat is apparently forming. So if anyone knows more about that and wants to come talk to me, please do. And yeah, really looking forward to seeing the outputs of that work. Now on to my third and final and probably biggest point. Achieving a 1.5 degree aligned pathway in restoring nature will require not just a change in how we produce food, but also what we produce, or rather, how much of what we produce. Retailers should provide customers with a more balanced choice of proteins. Reducing our consumption of animal proteins would mean using less land to grow crops for animal feed and freeing up land to grow human food. To showcase this, WWF has developed what we call the Live Well diet, a healthy, sustainable diet which, if adopted, could deliver substantial reductions to the UK's environmental footprint, including a 36% reduction in greenhouse gas emissions and a 20% reduction in biodiversity loss compared to the current average diet by 2030. And all that while meeting current government population, nutrition and dietary guidelines. But again, as Tom mentioned earlier, behavioral change is tricky, and this shift will not happen through individual behavioral change alone. Diets are not just a question of personal preference. Surveys and studies have shown time and time again that food choices are deeply influenced by the environments in which we purchase and consume foods. So what is available to us, what is affordable, and how it is marketed are huge factors in determining what and how much of what we consume. And these factors are determined by governments and businesses and are largely beyond the control of the individual. So delivering change will not just be a question of winning hearts and minds, but of changing these environments. And some forward-thinking retailers have already incorporated healthy, sustainable diets into their strategies. However, as you can see in this graph, we're still quite a way away from sort of aligning protein sales with the Live Well diet. It is still very heavily weighted on livestock proteins. So WWF calls on retailers to redistribute their sales targets towards foods that support healthy, sustainable diets, and embedding this in retailers' leadership and their operational DNA to connect the ambition across functions, so on health, sustainability, marketing, promotions, and category management teams. All retailers will have to adapt their business strategies to enable and support healthier, more sustainable food environments and purchases if they're to meet their nature and climate targets. So just to sum up and recap, retailers, I think, have a unique role to play in solving or helping to solve this peat problem by improving our understanding of peat in supply chains, fostering collaboration across the sector to incentivize sustainable peat management, and offering a more balanced protein choices for consumers. Retailers can take an important step towards addressing the triple challenge of food and nutrition security, addressing global warming, and reversing nature loss. Thank you.
Well, thank you very much indeed for that. Now we're moving on to the discussion part, which involves you guys out there as well as folk on the panel. As usual, I've just got a couple of questions myself. Did I understand that correctly? That now we get nearly 80% of our protein from meat. Is that right?
Thanks. Yeah. If you want to, is this working? Yeah. If you want to click back one slide, then I think, or two, yeah. You can see that at the moment the sales distribution shows that it's a very livestock-based protein sales at the moment.
There'd be a lot of dairy in that, wouldn't there? In the UK at least.
Yeah, I would recommend looking at the full report where it kind of looks at the different products.
Do you have any idea how this line compares to other countries? What's the proportion of protein coming from livestock sources, out of interest?
In terms of how much we import versus...
No. How much other, if you go into another country, would that percentage be different?
I think
interested.
The trend overall is relatively similar, I would say, but again, I would have to go back to the sort of full data to check.
One final question you may not have answered to. Can we really get 30% of our protein from fish? Seafood? I mean, we've got overfishing already. Farmed fish are already a problem. Can we really triple it environmentally, sustainably?
Yeah, so the analysis that WWF has conducted in this report, which I've linked in the slides as well, which is Eating for Net Zero, shows that we can, but you're right that it's not just a matter of increasing, but it's a question of how do we increase that sustainably, and we would have to probably do quite a lot of work in those supply chains as well. Yeah.
Yeah. Very good. I have a question for Ian. Just you were mentioning this thing about biology, physics, and chemistry. I heard it said to me that basically for many decades, it was a bit of a caricature, but for many decades after the Second World War, biology was kind of ignored in farming because it was difficult. Do you recognise that caricature?
Yes, yeah, totally. It was difficult, I think, because we couldn't measure it. We were hell-bent on actually always measuring stuff and having numbers to put against stuff, and it was very difficult to do that with biology. You talk to the sort of grandparents' generation, they knew stuff about biology, but they didn't understand it, if that makes sense, but they did the right thing by it. And then we decided actually we'd go into a very much more physical and chemical farming system. So biology was always been there, because we were all biological farmers, we're growing a plant or an animal, but we forgot that we were biological farmers. So yeah, I agree.
And how long has Hutchinsons been going for? Roughly?
The mic.
Roughly
85 years.
85. So for quite a lot of that period, your farming advice was worsening this problem.
I only joined the business 4 years ago. My job in joining Hutchinsons was to help the change. And I think the change has started. Good luck. You're being helped out by your friend next door.
So I'm going to make a comment about the other thing I think was that to deliver the control of weeds, pests, diseases and nutrition before the Second World War, not that the Second World War was causative in that, but we had to use biological methods, rotation and lysot-based systems and integration and so on. And actually the chemistry allowed that to be displaced. And it was a conscious thing, but actually it also allowed us to supply a lot more food, a lot more effectively. And what we need is a better balance of those things, rather than, in any case, whichever way we go, we need to not take our eye off a chemistry ball, because actually we'll disadvantage the biology. It really does have to be that balance between the three. But yeah, there is definitely a displacement of biology by chemistry, not so much by physics, but particularly by chemistry, from the sort of 1940s through to the 1970s.
And Nick, just a final one for me for now. What happened to the yield on your farm when you made this transition, and does it matter to you?
Well, I mean, our yields dropped considerably. We went from we had an average wheat yield at Ken Hill of 7.2 tonnes a hectare on sands and silts, and I'm sure all of you farming in the fens, 7 is a second or third wheat. Following something else, and it's really poor, we shouldn't be growing it, but that's just where we were. And that's
sorry, to be clear, was that on the soil you said wasn't worth it?
No, that was lower,
okay.
But on our better arable land, 7.2 tonnes a hectare, when we stopped using chemistry, we dropped down to, I think our lowest yield was about 2.1. We're now heading back up. And I think last year, and it's only 1 year, our wheat yield fluctuated from 5.1 to 3. So
what do you realistically think it can be?
Good God.
The farming method you've got
well, I think the water holding capacity, Tom, is the most important part, because we suffer in East Anglia on our sands and silts with this period of 2 or 3 weeks of dry weather. And we haven't got the water holding capacity in our soils because it's just sands and so they just drain away, and we lose yield considerably. So I could see us getting back up to that and maybe moving further up.
Back up to 7.
Yeah, absolutely.
So
with no inputs apart from maintenance, as Ian was pointing out, maintenance dressings to make sure the biology stays as a constant. Because if we do disturb the soils, or we do anything, we will see a drop, and that's this year's project, to see where we can take our nearly 0.6s and high levels of fungal to bacterial ratio with protozoas, and how quickly that would drop if we introduced a cultivator or something else to it.
And just briefly to the second one, my question, does that matter to you?
No, because our fixed costs have been reduced, and we are as profitable now as we were when we were still using the chemical systems. But our total tonnage has reduced, Tom, in terms of producing food. In terms of food. Food imports? No, absolutely not.
Can I add to that? I think if you take farming in the fens on certainly the salad and veg farms I'm involved with, going a regenerative has not had any detrimental effect on yield.
Really?
Yeah. But you're doing
which crops did you just say?
So salad crops, potatoes. But what the key there is that we've gone the whole system. It's not just picking one bit or changing cultivation or reducing fertiliser or doing a bit of bicrop. You're doing the whole system together, and we have not seen a reduction. I can create a reduction for you by doing that individual picking, but you have to take it as a system. And that's the whole mindset piece. It's not just about being trendy on Twitter and following that one or doing that thing. You have to do the whole thing, and you will not say, well, you should not see any yield drop.
Very good. My regenerative potatoes I showed a picture of in an area growing the size of this table did have a trailer the size of this table full of seaweed on top of it, so that probably helped quite a bit. Right, let's get some questions from the floor. Surely I should have scared a few up from you guys. You're all very quiet after lunch. Yes, from John, I think.
Yeah. What place does livestock play in regen farming? And I'm interested to know from Nick and Ian about livestock, and is this view that we halve the amount of protein we're getting from livestock impact on the future of our soils because we're taking grass out of rotations and potentially don't have the livestock to graze in the winter or whatever.
I'll start with you. Nick, you've got the mic. Yeah, you mentioned livestock, but carry on. Nick.
Okay, thanks. Thanks for that. Well, we don't see much livestock in our area, but we've got some amazing people with sheep, and we introduce sheep into the rotation as a roving flock. Yeah, I mean, I can't really answer the second part of your question, but we see it, certainly for soil health, we see it very, very important, and we have a rotation of introducing livestock within our complete rotation. As Ian said, it is a rotation.
And you said you can sort of make livestock analogues up to a point with microbiology, can't you?
You can, yeah. I mean, I've always loved to have livestock in the system. Sheep tend to be my favourite because you can graze cover crops off and help reduce some of your chemical inputs. But some of the places we work with, we haven't had livestock for 2 generations, and the infrastructure's not there. The public haven't seen the livestock for ages. They walk dogs and don't know what to do. There's a much bigger thing than just bringing livestock on. There's another part, I think, that as a country we're not growing enough protein anyway. So to feed the livestock we have, and that's part to do with the processors won't accept some of the proteins we can grow, and I don't think we've got the experience to grow enough homegrown protein, whether that's pulse or peas, beans, not lentils, but peas and beans to start with.
Yeah, just a little observation I'm thinking from, my book, when I went to see a champion yield farmer, Rob Smith, up in Northumberland, one of the things, and I fully expected him to be a chemical junkie, and he was using a lot of chemicals, but he was absolutely going down this road. And what he said to me was, next year, so that would now be this year, his son, who had just come out of, I think it was Harper, was going to start a livestock operation basically on part of his farm, because he realised that this was absolutely key to the future of his soils. And yeah, so I was going to just a quick question: are you seeing this? There was talk. I probably did Countryfile things about it 10 years ago about the livestock coming back east. Is that happening? Yeah, I don't know whether have you seen it? I mean, is it, or is it just a sort of journalistic fiction?
I don't think there's a big increase.
Right.
There's certainly more sheep about, but they may not be permanently here. There's like the flocks coming and moving in and about. But again, I just temper livestock. I love livestock, but please don't use livestock as an excuse not to start some of the things that have been talked about today. Mm-hmm. We can get there, we can work our way to it, and even if it's just a microbial livestock to start with while we're getting ready for four-footed ones.
Very good. Who else here? Yes, Lydia. And then...
So I've been to your farm, as you remember, and I love what you're doing.
Sorry, who are you pointing at?
To
Nick.
Penhill Estate, Nick.
Yeah.
But you had quite a buffer. I guess Nick had a bit of cash behind him, and I guess you get a bit of a buffer from the bead doing spring watch and whatnot. So,
can I just stop you there? It's the BBC, okay, isn't it, Tom? It's the there was no buffer, I can assure you.
I retract that bit. Anyhow,
please do.
Probably the question is to Ian, actually. Do you think that it is possible to take that hit on your yield and therefore your budget with the help of SFI? Do you think you can weather that drop in your finances?
I'm hoping not to give you a drop in finances, but yes, the SFI has some very useful things that can help in the rotations. So I would use them as best you can in the rotation that you're trying to do.
And we utilised, when we saw this happening, reduction in BPS, we took that point that we wanted a 5-year journey down out of using chemicals and use that buffer of coming down. So when we got to this point, we were coming back out the other side and not staring into, well, where's this money coming from if I wanted to do it. So that's why we took the decision we took.
Thank you. I'll come to you in a moment. I just wanted to ask Swaantje something. You said near the start of your talk, if the retailers are serious about meeting 1.5 and having policies to match, are
You have to ask the retailers.
I'm asking you as someone who has a relationship with them.
Right. I think the ambition is certainly there, and we're really happy to have this sort of public commitment from 7 of these really big retailers to go down that path. I would say there is still a way to go. It's a 2030 commitment, as I said, and we're still seeing there's a way to go still. And I think the first hurdle of that is even greenhouse gas monitoring in supply chains, which is still not being done across the products. So that would be a useful first step. But I would also say, I mean, I use this as a sort of starting point because that's kind of why we're here. But I think also to tell the full story, soil emissions aren't currently part of sort of third scope 3 emissions. So I think there needs to be more work done there in order to institutionalize that more and, build a market around it the same way that you would with carbon credits otherwise, potentially.
Isn't something where they've got to be careful? You talked about them managing their use of Lowland Peat in their supply chain. It feels almost like we're going to end up with sort of peat being something that's demonised in the supply chain. A little bit like, your exposure to forced labour or something like that. What's your exposure to peat? I mean, haven't we got to be very careful? Because, it can be managed. People here are trying extremely hard, and some of them are succeeding in managing it in a way which is much less environmentally damaging. So we've got to be quite careful about a sort of demonisation of peat, haven't we?
Yeah, certainly, and I think I want to make that very clear that that's absolutely not what we're aiming to do here. As I try to point out in the sort of 3 different asks in my presentation, I think it's about acknowledging that some crops might be possible and feasible to move off peat, whereas others might not be. And I think it's about having that really careful local analysis in place, which is currently probably not taking place enough. And I think, as I said, I think the opportunity mapping that Finland Soil has done is a really good step in that direction.
I think we also need to be aware it's not just retailers, so we need to be aware, as particularly farmers in the room, around BBRO sourcing and British Sugar sourcing via sugar beet. That's going to be an issue for them. It isn't just at the moment, but it's certainly on their radar. They're having those conversations. The big potato supply chain, so McCain's, PepsiCo, it's certainly on their radar. They're having those conversations and having a think about what it means. That isn't to demonise peat, but it will bring this discussion not just to be an environmental one, but also to be a sourcing one, and hence early conversations and engagement. It's not I think that's where WWF have done a really good job, actually, of promoting those conversations really early to start us all thinking about really what will sustainable sourcing from peat look like, and how we might then go about doing that most effectively.
And what are the unintended consequences if you don't get that food from somewhere else? Yes.
Thank you. Julia Casper, Harper Adams. We have a lot of discussions around regenerative farming and conservation farming at Harper. Some of them are quite heated. So, I don't know if it's a question really, but regenerative farming on peat, it's different. That is detailed out quite clearly. So, what is regenerative farming on peat? Is that something that you're hoping to achieve here with farming at high water tables? Just something for discussion. It's open to anyone to answer that one.
Do we want to take? I'm not sure if anyone is actually a regenerative farmer on peat on this panel. But
well, look, I had a go. I was for only a year and a bit. I was asked to help on a Fenland farm looking at regen farming. Some of the principles and practices that we looked at, and it was only a year. It was 2 growing seasons, and we have to bear in mind that the first year coming out of a conventional system, we still had some of the nitrates within the soil to buffer the yields, and it was the second year that's when we had the hit. And we were looking at those principles and practices, and some of the things we did worked very, very well on peat soils. I was desperate to have a go at introducing microbes from the soil samples that we took, very heavily dominant in bacteria, and I was trying to do something with the protozoa and the bacteria-feeding nematodes to try and recycle some of that, but unfortunately didn't have the opportunity because the management changed. And Velcourt came in, and the whole thing just turned around very, very quickly. So that is my only experience in it, but I just wish I'd had that other opportunity to have a go.
I don't know, don't pick it up if you don't have to, if you want to.
No, I don't think it sounds really stupid, but just follow the principles of what I went through, and we're changing through lower disturbance, lower cultivation, all those principles of which you could turn good farm practice, we're now doing on very black land and getting some very good results, with a lot less input into it.
Is that truly regenerative?
Is that truly
regenerative? These are the discussions that we have.
I'm not sure if I'm not sure there's enough of a sort of fundamental creed of regenerative agriculture to answer.
So I mean, and as Julie said, I tried to give us the clues to think about what that might look like in the presentation, and Megan's going to make us do some work in a little while to see if we can draw on experience from the room, because there is lots of experience in the room of people doing a whole range of things, managing water tables and looking at how that might feed through with really alternative crops and really alternative things going on, but also within just really sensible, good farming systems. But in the context, I think some of the principles are really important. So we know that minimising wind erosion on peat is critical. So soil cover is critical, but actually not all of them will work, I don't think.
I mean, there are a lot of people with G's labels in this room, and I've looked on their website and they claim to be doing regenerative agriculture, so they might have an answer for you. Let's see who else. I asked for...
I'm actually not going to come in, but I'm going to throw my colleagues under the bus and make them talk about it. So I wondered if one of the guys from GS Shropshire's wanted to volunteer themselves to talk about the PAF trial stuff. Yeah?
Just briefly, please.
I'm going to be at least 10 minutes.
Okay. we may have to go and get a cup of tea.
So, in answer to your question, fantastic question. Look, regenerative farming, arguably, we can frame it as being about changing soil biology from one paradigm to another. We're removing the bacterial dominant, we're replacing it with probably new bacteria mix, fungi and protozoa, so we're eating and churning those bacteria. If we look at, that's regenerative farming, if we look at the burning of the fen, the release of CO2, it's driven by bacterial consumption of the peat, fed by oxygen, powered by nitrogen, nitrates particularly. And we've spent years, 60 years, deeply cultivating the fens, piling lots of nitrate in. So we've been powering this process. So regenerative agriculture is about taking bacteria, fungi, protozoa, the whole soil food web to cycle nutrients, and we can feed nitrogen in other forms to our plants. We don't need the nitrate we've been using. So we can take a lot of the nitrate out. Once we change our farming systems, lighter tractors, modern tyres, we can take the compaction out of farming the fens. We don't need to do the deep cultivation. You know, naturally the fen is quite well structured, or has decent porosity anyway, so we can get air in the fens without us. We're doing this now very successfully. We're reducing our cultivations dramatically. We're using soil inoculation to introduce fungi, protozoa, species that aren't present in our soil food web at the moment. We're changing our bacterial mix. So if we put all this together, can we reduce the aeration of the soil to reduce the flow of oxygen? Can we change our bacterial mix, re-energise our soil food web, empower our farming with new, fresh, currently absent species in our depleted soils? That's absolutely how this, you know, we're transitioning, that Ian talks about transitioning without a yield loss. That I think this is a key question. Why would any of us accept transitioning to regenerative agriculture with a yield loss? And I suspect if you ask Nick, how would he do it now, knowing what he knows now, he would do it differently. He just told me he would. So,
can we leave it there? Is that
yeah.
right? Thank you very much indeed. You can, well, I was going to say keep the mic, that might be dangerous. A couple more quickly. I saw one there, and there was someone on that side as well. Yes, sir. Yes. Have you got? You haven't got a mic. You might get this side first. Then we will. I won't forget you. Promise. You'll be next. Whoever's someone over there had their hand up. Thank you. Yep.
A great deal of discussion about the about working in the fens has been about deep peat and the paludiculture. Of course, the data that we have from Cranfield on this is that actually only about 10% of the fens is deep. So about 90% of the fen is skirt or wasted. And doing water in management in skirt fen is much more challenging because you can't get the water in mechanically. What are we finding about this handling in skirt rather than in deep peat?
Does anybody on the panel want to pick that up, or is that a question to pursue over tea?
I'll say two things. One is that in each of those soils, depending on the deepness to shallowness, both mineral and fossil processes in terms of carbon and cycling are going on. Both we need to have account of, and both we need to manage. So on mineral soils, you simplify and you only have to worry about one. On deep peat, you run the other end. Skirt, therefore, is probably your hardest. But there are things we can do and we should be doing that can hold carbon and support good yields and keep that soil peaty, actually, which is really important.
The emissions are lower from, are they not?
Not necessarily.
No, not necessarily. Okay.
No, it's to do with how much peat is exposed and being degraded.
Yes, so if you put your hand up, then I'll know where to put the mic. Yep. Put your hand up and then someone will bring the mic to you. Oh, sorry.
Megan's asked somebody from Robertson just to make a brief comment about holding water tables. So we did we're a farmer who did a paludiculture trial on our farm, but we have got deep peat. We laser level our fields and we're able to hold a water table of 60 centimetres underneath our crops, and that definitely reduces the oxidation and certainly reduces the greenhouse gas emissions that are emitted. In the paludiculture trial, we held it up at 20 centimetres, and that was reduced the greenhouse gas emissions even further. However, we found it extremely difficult to grow the crops.
What was the crop?
We grew Chinese cabbage and celery, so they're conventional crops we're growing across the rest of the farm. And those two crops yielded only about 50% of the yield and showed quite several disadvantages of growing.
Thank you very much. And I have promised the gentleman. Sorry, sir. Just a quick one, please.
I go a bit further, so I reweight my peat completely. I started with it in Germany 7 years ago on a cattail field, Taifa, and we make fibers from this, but we also sold some to the University of Applied Science in
Fibers, did you say? As in, yeah, you make fibers.
Important, it's for peat-free substrates, made from plants growing on peat which is not emitting anymore. So they tested them. And this is about why we need more regenerative agriculture. Paludiculture is mostly also in a catchment area, so we are the last ones getting the water with everything in it. And one of the things we found in there, it has a name of picloram. It's in Effico from Dow Chemical Agrar, and it's sprayed on winter rapeseed in October and November, and tends to run off. October and November are rain months. It had a half time, I thought it was only with uranium, but this is also with herbicides. 3 years. 3 years after spraying, it's still half as strong. And its industrial name is Agents White, the sister of Agents Orange from Vietnam. And it's just in your rapeseed oil what you buy with Tesco. So we need more agriculture down the system so we can do our paludiculture, because our plants are bioaccumulators.
Thank you. I'll just say that's a very, very interesting comment. I just take that as a comment there. Just a final question from me to Nick. As one of those kind of sad middle-class people who's now got 5 compost bins, one of which is a hot box, which is, you know, the latest equipment. It's like an air fryer for your garden.
Thermophilic, yeah.
Yeah. What should I be doing with my watering can and the brown juice that comes off it?
You shouldn't be getting any brown juice off it.
No,
if you're getting brown juice off, you're watering it too much. It needs to be 50% moisture.
Right,
Squeeze
so
it,
so nothing
you
comes out of that
get
cap?
one little drop. No, you shouldn't be getting anything on it.
So, but you said that the stuff you could spread on the watering can in your field. I thought
that's an extract. So that's making the compost, finally working out what microbes you've got on it, then introducing it to water and making an extract and then applying it. You shouldn't be getting anything out of your compost bin.
I hope you're
doing it wrong.
Secret
You can employ me. I'll come across and show you to do it, Tom.
Okay, we must leave it there. It's time for a break now. I promised